Hello students, in this lecture we will see one more numerical on supermesh analysis. This is the numerical. Find the current through 3 ohm resistor using mesh analysis. And there are two current sources over here and there are 4 meshes. So first of all we will mark the mesh currents over here. So here I can assume current as I1, here as I2, this mesh as I2, here I am assuming current as I3. And here I am assuming current as I4. After this, can you apply KVL in mesh 1? No, because there is a current source over here. That means you can't apply KVL in mesh 2 also. Can you apply KVL in mesh 3? No, there is a current source. Can you apply KVL in mesh 4? No. So they are forming mesh 3 and 4. They are forming one super mesh. 1 and 2 they are forming one super mesh. So you can't apply KVL at all over there. So we have to go for super mesh analysis from the beginning itself. So first of all, if you talk about this 15 ampere, I am writing over here super mesh analysis. And if you talk about 15 ampere current source, then 15 ampere is going up. So 15 ampere is nothing but I2 minus I1. Correct? So there are actually 4 unknowns. First of all, I will build a strategy over here. There are 4 unknowns. So I require 4 equations. But somehow I have to eliminate one variable and I have to bring to 3 unknowns 3 equations. Then that is the only fair thing in mathematics. 3 unknowns, 3 equations. Or you can bring it down to 2 unknowns, 2 equations. But here if you look at the circuit, there is no current source present in the outer mesh. The last lecture numerical, if you see the current source was there and you have eliminated that variable. So here it is difficult to obtain 2 equation to unknown system, rather we will go for 3 unknowns 3 equation system. So this is from mesh 1, 15 ampere going up, I2 minus I1. Then I will write down about this 5 ampere. So before that I will again write down this in nice format. So minus 1 I1 plus 1 I2 plus 0 I3. And I have decided to eliminate I4, so this is equal to 15. This is my equation number 1. Now I will talk about this source, 5 ampere. 5 ampere is moving downward. So the net downward current is I3 minus I4. So I4 is nothing but I3 minus 5. So I will use this equation for substitution purpose, or rather eliminating I4. So I will not give any number over here. I will use I4. Wherever I4 arrives, I will assign I3 minus 5. So these 2 equations I have written by looking at the current source. Now I have to apply rather KVL in super mesh. Okay, KVL to super mesh, and this super mesh is formed because of mesh 1 and 2. Before applying KVL, you need to assign the sign for the voltages developed across the resistances. So I am traveling this path 9 ohm, then you go to like this one 5 ohm, 7 ohm, and you complete this path. This is a closed loop. So you have decided to move like this one. So I have shown this path and now I will apply. So minus 9 times I1, go ahead, minus 5 times I2 minus I4, go ahead, minus 7 times I1 minus I3, and we have completed the path is equal to 0. Only 3 resistances, I have counted those terms. So minus 9 I1 minus 5 I2 plus 5 I4, minus this will become plus, minus 7 I1 plus 7 I3 is equal to 0. So I will have minus 16 I1, okay, minus 5 I2, and then I will have plus 7 I3 plus 5 I4 is equal to 0. Now we substitute I4 as I3 minus 5 over here. So this will give 16 I1 minus 5 I2 plus 7 I3 plus 5 I3 minus 25. Be careful, 5 into 5, so it will become 25. So this is equal to 0. So in equation format, this will give me minus 16 I1 minus 5 I2, so plus 12 I3. This is equal to 25, and this is my equation number 2. Now I have to obtain one more equation by applying KVL in mesh, supermesh 3 and 4. So before applying KVL to supermesh, I need to assign the sign for the voltages developed across the resistances. So here I am assigning the signs plus, minus, plus, minus, plus, minus, and then here plus, minus. So KVL to supermesh, and the supermesh, which supermesh we are considering? Which is formed because of mesh 3 and 4. So I am starting at, let's say, this point. So minus 2i3, correct? Minus 2i3. So I started at this point. Minus 7 times i3 minus i1. Go ahead. Minus 5 times i4 minus i2. Minus 3i4. Okay, minus 3i4. And then we are coming over here plus 4. And we have completed the path. So plus 4, and that is equal to 0. So you solve this thing. So minus 2i3 minus 7i3 plus 7i1. I am showing each and every step over here. Plus 5i2 minus 3i4 plus 4 is equal to 0. So i3, and that's it. So here you will have minus 9i3, and then I will have 7i1. Then I will have 5i2, and then I will have minus 8i4 plus 4 is equal to 0. Now I have to substitute these things. So i4, this I will substitute over here. So I will have 7i1, I am just writing in nice format, 7i1 over here plus 5i2 minus 9i3 minus 8 times i4 is i3 minus 5 plus 4 is equal to 0. So this will lead to 7i1 plus 5i2 minus 9 minus 8, so minus 17i3. This will become plus 40. 8 into 5 is will become plus 40, plus 40 plus 4, 44. So on right hand side minus 44. Okay, slightly I am moving faster over here. Okay, you can check this thing. So there are three equations, and I have three unknowns with me. The first equation is over here, minus 1, 1, 0, 15. These are the coefficient and constant. Here I will have minus 16, minus 5, plus 12, 25, 7, 5, minus 17 and 44. So once you solve this thing using calculator, I will have I1 as minus 1.28 ampere, I2 as 13.72 ampere, I3 as 6.09 ampere, and that's it. So I4 I need to calculate. So I4 I will calculate using this one. So I4 is nothing but I3 minus 5. So that will give me 1.09 ampere. But the problem is not over yet. You have to calculate current through 3 ohm resistor. So 3 ohm resistor, where it is 3 ohm resistor? Yeah, over here. So it is quite simple. Current through 3 ohm resistor is nothing but I4, and which is moving downward. Okay. So this will give me answer as 1.09 ampere downward. Thank you.